settings, it might be wrong. Okay, so this question 6a. Harry is finding different ways that he can arrange 4 equilateral triangles edge to edge. So equilateral meaning that all these sides are of the same length. Sometimes that's shown by having these little dashes on there. He makes 3 different shapes. How many lines of symmetry does each shape have? So shape A has a line of symmetry through one vertex or corner straight through the other side. So there'll be one through this vertex and one through this vertex. So there are 3 lines of symmetry on that shape. How many lines of symmetry does shape B have? Well, that's a parallelogram by the time you've put those 4 triangles together, and they don't have any lines of symmetry. So that is 0. And shape C seems to me to have 1 line of symmetry that runs through that vertex there. So that is 1. What is the order of rotational symmetry of each shape? So that means in how many positions, if you rotate it, does it look exactly the same? So shape A would look the same whether that corner's at the top, that corner's at the top, or that corner's at the top. So that has rotational symmetry of order 3. Shape B would look the same if that's at the top, or if we span it round and that was at the top. So that has rotational symmetry of order 2. And there are no other positions in which shape C would look the same. So the order of rotational symmetry of that is actually 0, although the mark scheme will accept if you put 1, but technically it has no rotational symmetry if it doesn't look the same in any other position. What is the perimeter of shape C? Well, if we return to the start of the question, it said that all the sides were the same length because it was an equilateral triangle, and that side length there was 1 centimetre. So every side length of every triangle is 1 centimetre. So the perimeter of shape C is 1, 2, 3, 4, 5, 6 centimetres. Okay, moving on to part B. It says Megan is finding all the different, let's get this straight. Megan is finding all the different ways she can arrange 4 squares edge to edge. The squares all have a side length of 1 centimetre. She makes these different shapes. Megan finds a new different shape made with 4 squares joined edge to edge. This shape has 1 line of symmetry and no rotational symmetry. So I need to put 4 squares together, ensuring I put them edge to edge, to make a shape that has 1 line of symmetry and no rotational symmetry. So I think that if I were to do this to make a kind of T shape, that would have no rotational symmetry. There's no other position when I rotate it in which it would look the same, but there is a line of symmetry that runs down the centre there, so that will get me the mark for that question. Moving on to part 2. She finds another new different shape made from 4 squares joined edge to edge. This shape has no line of symmetry and rotational symmetry of order 2. So if I put this shape here, that will have rotational symmetry of order 2, meaning it will look the same in 2 positions. So you can imagine me rotating that 180 degrees, it will still look the same. And does it have any symmetry? It doesn't. So that's the answer to part 2. Part 3. What is the smallest perimeter of shapes made with 4 squares joined edge to edge? Well, whenever I put squares together, I need to minimize the number of edges that are not touching other edges, because when they touch, obviously this edge here, they no longer count as the perimeter of the shape. So basically what I do is I want to arrange them with as many touching as possible. So typically that's going to be a square or a rectangle if there's not the right amount of small squares to form a square. So this will mean that I'm only showing 2 edges off of each square, because as many as possible are touching. So that gives me a smallest perimeter of 8. Now I wouldn't actually draw that on there because that's part 2, that grid, but I was just demonstrating it for purposes of this. What's the largest perimeter of the shape? So here I need to minimize the number that are touching each other. So the way to do that would be to spread them out as much as possible. So this would be one way of showing how as few as possible sides are touching. That would mean I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as the maximum perimeter.